Okay, let's go. Let's start. It's recording. Okay, so the conservation of mass, it says because atoms cannot be created or destroyed in a chemical reaction, the mass of reactants is always conserved. So basically what this means is like if we start out with 300 grams at the first, we should end with 300 grams. If we lose any, then that's because there's something wrong. Something can't just go up into thin air unless there's evaporation. So if it's a liquid, some evaporation might happen. But if it's in like a closed container, you shouldn't have that. So in the other words, the total mass of reactants must equal the products. So you guys would know which side is the reactants of an equation. Yeah. So this side is the reactants, this side is the products. Just let me Why is this not going full screen? Okay, so this is the next topic. It's talking about losing and gaining electrons. So it's in a single replacement reaction. You remember what that means? Single replacement. We learned about it in Science 10. So this is a single replacement reaction. Single replacement means that you have like a compound. So Fe and O, so two elements together, and then one element by itself. And then they switch. So now this Fe is by itself and Al took its place. So it's sort of like, I always said it was like a couple, and then someone who's single, and then the couple breaks up, and then the single person goes with one of the people that was in the couple. If that makes sense. That's what single replacement. They're not single anymore. The aluminum was single, and now it's with oxygen. Okay? So it says in this reaction above, the oxygen in Fe2O3 reacts with aluminum to form Al2O3 and pure iron. During this process, aluminum loses electrons, forming an ionic bond with oxygen. Iron gains electrons to become stable. Okay, so what all that means, and this is really important that we get this, because this is, and that this whole part is basically on this point, or you're going to be looking at this. So look at the FeO3 there, Fe2O3. Can we break down this molecule? Break it down into its, I guess charges is what we want. Can't go backwards. Okay, so breaking this down into its charges. Let's break this right in half. Do we know what the charge of oxygen is? 2. 2 what? 3. 2's right. 2 what? Positive or negative?
Negative.
Negative. How do you know that? Because you can see it on the periodic table? Yeah, so on the remember back to the periodic table, and you guys should have one. Do you have one? That big one that I gave you? Yeah, you might want to get that out. So the periodic table will tell you what the charges of these things are. Sort of. Definitely oxygen. So oxygen, Alyssa said, is -2, which I'm going to write there. So oxygen's a -2, and there's 3 of them. So what's the overall charge of the oxygens there? Yeah. 6 what? Negative or positive? Yeah. So it's 6. So he's getting 6 by going -2 times this little 3, and that gives us 6. So this whole side is -6. Remember in compounds it needs to be balanced? Remember in Science 10 we had to do all these balancing? Like the crossover whale whatever we called it. Yeah, so if that right side is -6, that means the left side has to be what? +6, yes. So remember, we have to have the same amount of positives as negatives. So that other side has to be +6. Well, there's 2 irons there, so 2 times what gives us 6? 3. So we're saying that every iron there is a +3. Do you understand how I got that? So we don't know what iron is because iron is it's number 26. So iron's right here. And if you look at it on your periodic table, there's 2 possible charges. So in that one, we have to go backwards to figure out what the charge of it is. Okay? Now that we know that, we can do this question. Well, I guess we can try. So what this question is asking is we just need to figure out which of the elements is gaining electrons when it goes from one side to the other, and which one is losing. All right? Hi.
Have you just wanted, do you have another 50 milliliter beaker?
50 mils?
Yeah.
Okay, so let's look at iron. Let's do iron first. So iron, it is a +3 on the left-hand side. And then when it moves from the left-hand side to over here, it's just Fe by itself. When it's an element by itself, what is the charge?
What?
It's a good guess, but no. Close.
3. Oh, 5.
So the key word here is it's an element, not an ion. What do elements have? Do elements even have charges? When it's not connected to anything, it shouldn't have a charge. So the charge of Fe there should be 0. So whenever you see like an element like this, just with a solid beside it, that S means it's a solid, that means it has a charge of 0. So I'm going to write that above 0. Alright? So from one side to the other, we went from +3 to 0. That's what iron did. So did iron gain electrons or lose them?
Lose.
No. Are electrons positive or negative? They're negative. So we had to put at least 3 negatives to the iron to make it 0. Right? Because it's at 3. It's hard to
Take them off.
take what off.
3 positive.
Yeah, so we had to add 3 electrons to get rid of those positives. Does that make sense? So yeah, they had to cancel each other out. So to cancel out those 3 positives, we had to add electrons. So the Fe, I'm going to say gained. Looks really bad. It's really hard to write with this terrible Amazon pencil. Okay. I know this is it's a little bit of a big topic. This is a topic that's in Chem 30. Why they teach it to you in Science 20, I don't know, but it's once we get our head around it, it won't be too bad. So let's check on the oxygen. The oxygen on the left-hand side is -2. On the right-hand side, it's in a molecule. So it's also going to be -2. So whenever they're connected to another thing, they're going to be in their ion form. Okay? So oxygen never changed. Alright? So that's a pretty good hint that if the other one gained electrons, well, aluminum's probably the one that's gonna lose, right? But we'll check it out. So aluminum on the left-hand side is what? What's the charge of that? It's in a solid, it's not connected to anything. It's what?
0.
Yeah. So whenever it's by itself, it's going to be 0. So our aluminum is 0, and then on the right-hand side, we can look at the periodic table for aluminum and find out what the charge of it is. Because it only has one charge, your table should tell you.
3.
Positive or negative?
Well,
All right, so from the left to the right, the aluminum, did it lose or gain electrons? It went from 0 to +3. Remember that electrons are negative, so it actually lost electrons because it became more positive. I know that's hard to get your head around.
so electrons are negative.
Electrons are negative, so when something becomes more negative, then you're gaining electrons. When something becomes more positive, you're losing electrons. So gaining electrons is more negative.
What's the positive?
Losing electrons is more positive. Okay. So aluminum, it became more positive, so it lost electrons. It looked like I wrote that Al lost electrons. Okay. So that's the first example. We're definitely going to do another one. And maybe that's confusing all of those lines up there. Try to make different colors. I don't know if that's helpful.
Okay.
It looks like a mess. Does it look like a mess?
No,
I could get rid of some lines here. Let's see. Some ones that were not important. That's about all I can get rid of. That might make it a little better. All right, can we go on to the next slide? Is that okay? So they explain this one on the next slide. So this type of reaction is called a redox reaction. And a redox is reduction and oxidation. It says the process of losing electrons is referred to as oxidation. So when something loses electrons, it becomes oxidized. What does oxidized mean? Well, you guys see it probably every day in your life. Things are oxidized. It's like rust. Have you seen rust on metal?
Yeah.
Things rusting. That's oxidizing. So as metal rusts, it loses its electrons. Okay? That's what is happening in rust. So in this reaction, aluminum oxidized. Okay? So this aluminum, it was metal, and then we put it into this solution, and it became rusty. The process of gaining electrons is referred to as reduction. In this reaction, iron was reduced. Okay? So we already did this one on the other slide, but it's showing us here that the Fe gained 3 electrons and the Al lost 3. And that's what we said, right? Low gaining, so we did it right. Yay.
They were in college, he used to be
He went to his Florida's office. Leave us. Okay, so this is a way to remember this. I honestly, when I was in high school, my teacher taught me oil rig.
Leo line says you're
So I don't know if you'll remember that.
oil rig.
I remember oil rig. O is oxidation is losing. Reduction is gaining. And that's what I did for oil rig. So, do you see that?
Yeah,
So oxidation is losing, reduction is gaining electrons.
I like oil rig better.
I prefer oil rig. Every textbook that I've seen as a teacher has always said Leo the lion says grr.
That's so bad.
What does the LEO stand for?
Loses electrons oxidized, gains electrons reduced.
Oh,
But you have to remember Leo and grr.
Leo.
So yeah, that's what all of the textbooks say that I've been a teacher. When I was a student, my teacher called me oil rig. So oxidation is losing, reduction is gaining. Okay? Whichever one you want to use to remember, that's up to you. So it says any chemical reaction involving gaining or losing of electrons can be broken down and written into two half reactions. The oxidation half reaction describes the element that's losing electrons. The reduction half reaction describes the element gaining. So what this all means is that we can actually split this up. So this one we just did, you can split it up into two half reactions, they call it. So the first half reaction is this. So the one on the bottom there, Fe. So they write Fe plus 3 adds 3 electrons, which gives us the Fe solid. Okay, so it was gaining electrons, right? Oil rig. So reduction is gaining. So that's the reduction half reaction. The second one, aluminum, they've just split it up as well. They've just split this up as well. The aluminum, so the aluminum solid, which is right here, is broken up into the ion by itself, and that's losing 3 electrons. Okay? So the electrons are added to the side. The left side is gaining. And the right side is losing. And then something that's really important is that the oxygen, remember how we saw that oxygen just stayed the same? So it was -2 and it was -2. They call that one a spectator ion. So it doesn't really do anything in the reaction. It's just a spectator. What's a spectator?
They don't do nothing.
What do we use that in another term? Like in our life?
He watches like someone standing on the side watching.
Yeah, watching. So like a spectator, as people watch sports.
Yeah.
Right? So that's what oxygen is. It's just watching. It doesn't actually do anything to the show. Okay. Aluminum and iron are the stars of the show. So here's some practice ones. It says determine whether each of the following half reactions represent oxidation, reduction, or spectator ions. So are these ones that are in your review, or is this ones that we do together?
These are practice questions.
They're just ones that these are the same ones in there.
CO2.
These are the same.
Okay, so they are, so it's different. Alright, so these are ones that we should do together. So let's try some of them. So the first one, Cl, 2 plus 2 electrons gives us 2 Cl. So remember on the last slide, I literally just told you this, and maybe it'll help you. Whenever we see the electrons on the left-hand side, see in the very first one here with iron, that means it's gaining electrons, right? If it's on the right-hand side, it's losing. So if we go back to this one, we don't even have to figure out the charges because the electrons are written on the left side. So whenever they're on the left side, it means gaining. So is gaining oxidation or reduction?
Oxidation, reduction.
Just said oil rig. Which one has the G in it for gaining? Oil
Reduction.
rig. Reduction. So we would write reduction. I'm just going to put a big R, if that's okay. To say it's reduction. Okay? So that one's gaining. The next one, the electrons are on the right-hand side. So that means it's losing electrons in the process. So when we lose electrons, is that oxidation or reduction?
Oxidation.
Yeah. So remember that oil rig. This is not working nicely. The next one,
Gain.
so they didn't write the electrons in there, so it's not easy for us to see. At first sight, I'd be like, oh, there's no, like in the last two, it said like 3 electrons. So I was like, oh, it's a spectator, but is it a spectator? Answer is no. So we can analyze this one. So O2. What's the charge on that? Or what's the charge of our O2? Oxygen by itself. It's not connected to anything. It is -2. So oxygen can never be by itself because it's connected to another oxygen, right? So when it's connected to another oxygen, it still is in its ion form, which is -2. What is it on the right-hand side? It already shows you it's -2. So is this a spectator? Or is it? Yeah, it's a spectator. It doesn't change. So we would write S. For spectator. Okay, Na. I think this one's pretty easy just by looking at it. Do they change?
No.
They're both Na plus, so it would be what?
Spectator.
Spectator. And then the last one, we look at it, is it changing?
Reduction.
Is that a guess?
Yeah, it was a guess.
Okay. How do we know?
It has 4 plus.
And what's Sn on the other side? What's the charge on an Sn solid? That S, that solid, is telling you a lot. It's just in its
Sulfur.
element form. That's tin.
Oh.
But the little s said it's a solid. What is it in its element form? What's the charge on it? What's there? Lisa? Are you doing it with your fingers? Yes. It's 0. So right here, this charge is 0. It's always going to be 0 if you have a solid metal by itself. Okay? So then the other charge over here is +4. If we go back to what we talked about before, Something that is becoming more positive is losing electrons. This is becoming more positive. So which one is that? Is it oxidation or reduction? Oil rig.
Oxidation.
Oxidation. So do you see how we figure that out? It's a little bit complicated. To be honest, when I was in high school, I did not understand this at all. I think my head just didn't work properly to understand this, but there's just some things you gotta remember, and oil rig will help you, I think, the most, or your Leo the lion, but just remember if something's losing electrons, and I'll write that on here. So if something is becoming positive, it's losing electrons. And if something's becoming negative, it's gaining. So those are like literally the two things you need to remember. Becoming negative is gaining, becoming positive is losing, and then oil rig. And I think those would be all you need to figure these out. Are you okay?
Huh?
So are you okay?
Kind of.
What's wrong? So we've got more practice on the next slide. Would you like, are you okay to go there? Are you still writing something down? You're okay? So now it's giving us flow reactions and they're asking us to figure out what everything is. I don't know if it would be beneficial for me to write it on the other slide. I will. So then there's-
She's nasty. Real nasty.
What was nasty?
Food every day.
It's definitely not half as good as it was before.
Not like last year's.
Yeah.
They probably just cook it right at 8 in the morning. No, like 7 in the morning.
Here,
Yeah.
the food we eat is cooked the day before. I think that's why it's so bad.
Oh, yeah.
Because it sits like in the fridge.
Yeah.
So it makes it like
Mushy.
some stuff. Anyway, okay, let's try this. This is your first example. Let's see how we do this one. So we need to figure out what's being oxidized, reduced, spectators. So let's start at Zn. So if I'm going to draw an arrow that goes from Zn to Zn, just because we're going to be comparing them. Zn on the, you can't even see that arrow, can you? On my screen it looks like much brighter. This is why these smart boards are so terrible. Maybe I'll do a different color. Does that work?
Yeah.
Okay. So from Zn to Zn, the one on the left hand side, what's the charge on that?
It's by itself.
By itself, 0. Good.
Yeah.
I should not be writing it for you.
There's an S by it.
Yeah, there is. I didn't write this in. Is that okay?
That just means it's solid.
It's a solid, it's by itself.
Solid.
So it's 0. Let's look at the Zn on the other side. Do we know what the charge of it is? Can we look at the periodic table and find it out, or is there more than one charge? Should be in like 20-ish, high 20 area. Maybe it's like copper.
30 zinc.
Is there a charge for it?
Plus
Is it only +2?
2. Yep.
Okay, so if there's only one possible charge, we don't have to figure out anything, we just know it's +2. So, write that. +2. Okay, so from one side to the other, what happens to it? Does it become more positive or more negative?
The electrons, right?
It's becoming more positive, so when something becomes more positive, does it gain electrons? It loses them because those are negatives. Yeah, that's the huge thing you gotta wrap your head around.
Positive. That and it's
Yeah, it's losing electrons. I need the poster that says this stuff so that you always can see it. Can you even see that written in red? Oil rig, something that is positive or becomes positive. Something that becomes positive is losing. Becomes negative is gaining electrons. These are all the things that we need in the back of our mind when we're looking at these questions. You did write it down, you should have, I just write it over here. Mm-hmm.
You use toothpaste.
Sure. Yeah.
They don't think for me.
It's a clean color.
For my room. Just look at my toothpaste. Just look at
Why is your toothpaste in your room?
I don't know.
You don't share toothpaste in the bathroom?
No, because they yes.
You keep your own toothpaste and bring it into the bathroom when you go to brush your teeth?
You don't?
No.
Oh yeah, because they're early, but you know.
I actually don't share a bathroom with them, so I guess I don't have the.
Oh yeah.
But you if I did share the bathroom with them, I would share toothpaste with them. Why would you share? It's not like he's putting it in his mouth or something. You put it on the toothbrush. I didn't know that people didn't share toothpaste. That's funny. Anyway, moving on. So our zinc, it went from 0 to +2, so it is becoming positive. So that means it's losing electrons. I'm going to write losing there. So when something's losing, is it being oxidized or reduced?
Oxidization.
Big O there for oxidization. So just by figuring that out, process of elimination probably means that, oh no, we can't do that yet because there's a spec here. I guess we gotta keep figuring it out. Okay, so let's choose another color that hopefully you can see.
Green.
I picked green, but I don't know if you'll be able to see it. So let's do the H. So from the left to the right, on the left, what is it?
HCl.
Yeah, do you know what the charge of H is?
2.
No.
1.
+1.
That's one.
I don't know why I can't write it on the top. So that little thing is saying +1 for the H. For the Cl, that Cl is -1, which you cannot see. It looks so nice on here, but it's silly. Do you see purple?
I see white, yellow, and dark green.
Do you see the purple?
And blue.
The -1 on the Cl?
I think I see it.
You think you see it? Yes. Alright, so that's, the H is a -1. If we go on to the right-hand side of the equation, it's H2. H2, it is hydrogen by itself, but it's connected to another hydrogen, which means it's in an ion form. So that means that this one's also -1. And of course, that little arrow fuse in the way. -1, +1 third. So if hydrogen is +1 on both sides, then what does that mean it is? It doesn't change? Is it oxidizing, reducing, spectator? It's a spectator. Alright, so then now we have a good idea of who the reducer is. Probably chloride, right? 'Cause that's the only one left. But we will double check. I hate drawing more arrows. Sorry, little lines. So from the Cl on the left hand side, it's a -1. On the right hand side, wait, it's also a -1. Maybe our H's they don't consider as being negatives. What I'm saying? So our chloride is not changing, because chloride is the -1, right? On both sides. It's not changing? Or is it? It's not changing. Right? Cl2, so there's two -1s that balance out Zn plus 2. So maybe this one is really the spectator. Sorry, I guess I'm gonna double check this, but let's write this one as being the reducing one right now. The hydrogen. So hydrogen would be the one that's gaining. I'm guessing that this actually is 0. I'll have to double check that because they technically are an ion form. I'll have to double check the hydrogen. But for this, I guess we're going to say that hydrogen was a +1 because it was with the Cl, and when it's with itself, it isn't, so it becomes 0. I'm going to double check that one. So we're just going to say that it's gaining electrons because it's becoming more negative. Because from +1 to 0 is more negative. So when you're becoming more negative, you're gaining electrons, and that's the reducing. Okay? Sorry I'm confusing you. Sorry I messed up. It's been a while. I looked at this all this morning too, like to double check that I was like, knew what I was talking about and not messing up with you. But I'll for sure double check that hydrogen. But yeah, let's try another one, can we? One of the other practice ones. So let's do the number 2 of the practice, so it's just NaCl. So there shouldn't be any spectators here. So what is the Na on the left-hand side? What's the charge? Is it? If you look back to yours, your Na is solid. It's solid by itself. So our charge is always going to be 0. What's our Cl? See, what I would say is it's a -1 and there's 2 of them, right? That's something I'm going to have to double check. So let's do the Na first. Just going from one side to the next. So if we go from here to here, our Na was 0 on the left-hand side. What is it on the right? It's connected to something, so it's going to have a charge. What's the charge of Na? Positive what? 1? It's a positive 1. So from one side to the other, did it become more positive or more negative? From 0 to +1. It becomes more positive, so we look at the board. It's losing, which means it's what? Oxidizing or reducing? So that should be your, what's on the board is like our little cheat sheet to always know that's oxidizing, right? So then the next one, if we look at it on the right-hand side, Cl is always going to be a -1, right? This should be the reducing from here to here. I'm doing this backwards just to see what this would have to be. So if this is reducing, then I'm guessing the Cl2 by itself is going to be 0. So it goes from 0 to -1, so it becomes more negative. That's gaining. Oil rig tells us gaining is reduction, right? So I guess I was totally off when I said that Cl2, H2, all of those ones, if they're connected to something, they would have a charge, but we're going to guess that that means that they don't. So any sort of thing on its own, even if it's 2 of it on its own, we're going to say it is a 0. Okay. You want me to do the last one? You guys can tell me what to do. Why did they have HOH? It's just H2O. Do you see that? So what is it? Ca? H2O? I'm not gonna write it HOH. That's just weird. CaOH?
Let's do HOH. So what HOH and 2 is H2O?
Yeah, because there's 2 H's, right? 2 H's and 1 O would be H2O, not HOH. I don't know why they put, wrote it out like that. It doesn't in case it looks weird. And then what have we got? H2 gas, I think. Sorry, I'm right off the edge, but it's really bad at spacing out on this. Is it H2 gas at the end?
Oh, yeah.
Okay. Right away, we know just from our last question that something like H2 gas is going to be 0, right?
Yep.
It's by itself. What about Ca?
0.
By itself, yep, 0. So let's do our calcium. Let's go calcium from here to here. What's the charge of calcium on the right-hand side? Positive what? 2. Positive 2. It's in the periodic table. You guys can see that if you find it. +2. Perfect. So from the one side, it went from 0 to +2. Did it become more positive or more negative? Positive, which means losing, which means oxidizing. Okay. H. Maybe that's why they wrote the H's not together. I'm gonna guess the H's. The H's are probably gonna be the spectator here, only because there's multiple H's. See how we've got H's in many different places? Like we have H2 and we also have OH. I'm gonna guess that oxygen's probably the one that we're dealing with here, so let's look at oxygen. What's the charge of oxygen on the left-hand side? So this is a hard one because oxygen, when it's with water, do you remember molecular and ionic? That might be hard to remember. But remember, molecular things are only two or more gases together. And oxygen and hydrogen are both gases. So when those are together, they don't have charges. It's not an ionic compound. So the charge of oxygen on the left-hand side should be 0. Because it's with another gas. It's not with a metal. Okay? So because that's with a gas, that's why maybe they gave you this as an example. So it's a 0 there. So if we go to the other side with oxygen, well now it has become not a gas, right? It's with a calcium, like it's connected to that calcium, so it has a charge. What charge does oxygen have on the other side? 0. So OH has a -1 charge, oxygen has a -2 charge. Regardless, this is becoming negative. It's a -2, sorry. If we look up oxygen in the periodic table, it's -2. So if we go from one side to the other at 0 to -2, that means it's becoming more negative, which means what? Reducing, yeah, it's gaining electrons, which means it's being reduced. Okay? Is that a lot to handle? Not a lot? You could do one of these on your own? Maybe. Okay, so that's where I'm gonna stop right now. I know it's a lot of information. I wanna see, let's see if I have Kleenex.
For real? Better than these?
Yeah, like
This one?
just on my little table there, there should be Kleenex.
I might get the top.
Yeah, so you can do number 5. You can do number 6, and that's it. Okay, so there's just 2 questions that go along with what we just went through. Alright? Does that seem okay? I'd like to try and finish this. How would we do